So it's my distinct pleasure to introduce the next speaker, Todd Robinson. He's the president and co-founder of InMotion Hosting and OpenMetal, among many other brands. Todd is kicking off the first of the AI sessions at this year's event, and he's going to talk about private AI and CPU and GPU inference.
Cool, thank you, Sash. All right, so I'm going to start out the AI discussion with a disclaimer. Actually, I got two disclaimers in here. So first off, this is not my deck. The proper engineer was not able to make it, so I will try to do it justice. The other one is, I use this as an example. So if you guys don't mind, grab your phone there. And so I've approached AI from a lot of different directions over the last couple of years, whether trying to learn it myself, whether as part of the business, whether as an infrastructure provider. But I always want to say something like this. This is still in the early days. So, but I use this example. So if you want to go on your phone or your favorite AI, ChatGPT or whatever, and look up what's the best way to take my kid's temperature. So grab your phone really quick. So you guys can help me out because I was warned by Sash to not actually answer the question the way that AI answered the question. So as you might imagine, for those of you, if somebody just wants to raise your hand and you can say it out if you'd like. It has gotten better, but the first time that I did that, I was like, oh, my kid's 11, and so yeah, that's not cool at all. So that's my disclaimer to get us started, because AI is still in its early zone. So yeah, I see a few people who have looked it up and said, yeah, I probably wouldn't say that out loud. All right, so. Yes, so yeah, it's all right, people still getting there, all right. So a little bit about InMotion, I'm sorry, a little bit about OpenMetal, and then we'll dig into a couple of these things around private AI. I'm gonna spend a little bit of time on the virtual GPUs, but we did that talk actually not too long ago, so we got a QR code up there for more in-depth details for vGPUs. Yeah, and then a couple other things that we got up there. So, but a little bit of background on OpenMetal is, so OpenMetal was founded out of a company called InMotion Hosting, and at InMotion Hosting we were utilizing OpenStack and Ceph for many, many years. And in fact, we had multiple versions of OpenStacks in various different parts of the business. And so we said, hey, you know what, this is pretty complicated to have this separated. Let's consolidate this down, let's make a standard system. So we partially did that, and as we did that, we realized, like, look, I'm a big open source guy. I got into the world of like CGI with Perl back in the day. But I was able to change from being an engineer, an automotive engineer, over into the computer science world. And so I have this real fondness in my heart for open source. But we had been using Ceph and OpenStack for many years and realized, you know, we were able to architect new, fresh OpenStacks with confidence. But one of the barriers for OpenStack was the ease of adoption for this system. It's very complicated, and if you're architecting it for the first time and you had never been like an administrator of a really good OpenStack, you're really setting yourself up for some difficult days ahead. And so what we decided was that, hey, actually, since we can productize this, we're also a hosting company, we've got hardware easily on demand. So essentially we figured out how to spin up a 3-server hyperconverged with Ceph, highly available 3-cluster system, and basically just spin it out almost instantly. It actually takes like an hour. It takes maybe 45 minutes to 90 minutes, depending on the servers themselves, to warm themselves up to that state, you know, from ironic all the way up. And then it comes out and it's finally injected with your last customer details, and then it's handed back to the customer. And so to the customer's perspective, it's literally 45 seconds. It's just injecting the final pieces in. So that's what we do. That's where we sit in this space. So let's see here. This is the team that would have been speaking today. Unfortunately, yeah, so if there's any mess ups, the guy on the right over there, that was him. No. So actually, Rafael Ramos, who's up there, very, very, very talented and has done the bulk of this work. So I unfortunately don't get a whole lot of time on the keyboard directly with this stuff, but I'm very familiar with it, both from being in an open source, AI-centric startup and having experience from that side, being a hosting company, as well as being an infrastructure provider and, of course, a user myself. But yeah, if you want to get a hold of either of us, we are up there. All right, so quickly, what is private AI, or my perspective at least on it? Yeah, so this is you doing it yourself on your own systems. You can absolutely use CPUs and GPUs. You should, as you go down the AI world, you're of course going to need to have a deep familiarity. So I wanted to touch on a few of these things as we go through them, but there's some of the obvious ones is, data privacy and security. But I also like to say, it's not up on there, but I also feel like when you're doing it yourself, or you're enabling your company, or you're enabling your customers to do it themselves, there's a certain amount of like velocity that you can get out of this because you actually understand it. And it gives the team, your teams, yourself, different directions that you can take with it. So again, I'm a huge advocate of private AI. This shouldn't only be, out there with the mega AI companies, or whatever we want to call these mega companies nowadays. So I listed down there, fundamental understanding is you'll get this familiarity, but I would also say if those are foreign things to you in the AI world, you want to go learn about them pretty quickly here. So yeah, the model resources versus capability versus cost, that's going to come together for you. You need to know reinforcement learning, quantization. This has obviously happened in the last year and a half, 2 years, where the companies have really realized you don't need to run these models at extreme precision. Floating point 32 that's up there is like a lot of math that wasn't really necessary, and so a lot of the models have been quantized down to int8, which is a much more reasonable way to go about it. Yeah. So distillation is that's one of my favorites at the moment, but that's essentially when you take a pre-existing model and you can run it through basically an educational process where you train, as you transfer the information, you're training specifically against something that you may want, and essentially you can take a really large teacher LLM, which might be running in memory at, I don't know, 80, 100 gigs, very, very large, not practical to really run except for very specific spots, and you can drop it into a student LLM, and so this might be like a Llama 3 something quantized and maybe quite small, and it'll turn out to be like maybe 3 gigs in RAM. So something, these are areas that you're going to want some familiarity in. Mixture of experts, it's been around for a little bit. It was popularized and brought kind of focus by DeepSeek recently, and that's essentially, they have this monster model that, actually it's kind of funny when DeepSeek kind of came out in the public eye, and you saw NVIDIA tank stock, and then like 4 or 5 days later, NVIDIA releases the NIM that's specific for DeepSeek, and you can only run like the full DeepSeek thing on some giant cluster. It's a huge model. It's really large. Yeah, so if you can see, the original model is a very, very large one, and essentially you have to use these huge systems. Now, if you're distilling it out of there, yeah, you obviously can get to a much smaller model. So mixture of experts is pretty cool stuff. Let's see here. Okay, so yeah, tipping point. When is private AI viable? And I think the biggest lesson here is that as the models become easier to use and the kits are more standard, so some of them are listed up there, NVIDIA NIM, for example, Llama VLLM, as these are more and more standard, they're just a lot easier to use. They're a lot easier to pull in, and so I've even watched some of the developers essentially flipping back and forth between using OpenAI's API and flipping to a local LLM trivially within their applications. And so they're really just getting a lot easier to learn and to use. But still, you're going to still want to have some of these fundamental understandings that I'd mentioned before. So one of the things we're going to actually cover really quickly today is that to help people have really ease of access to it is that these models have gotten small enough where the CPUs are starting to become viable for many use cases. So it doesn't mean your fastest use cases, it doesn't mean your most demanding use cases, but it does mean that it's possible and people can learn on it quickly. That one I think I might have run through already. All right, yeah, so over on this one, yeah, again, GPUs, of course, are really king for training. You're not going to get around that, but unless you're, the $100 billion company, you're probably maybe not even into that game. Certainly you can do it, but in most cases we're talking about inference. And so inference, we have now found, so we do this on several, I'll get to some tests here in a minute, but we do this essentially because different customer models can require, hey, let's say I need a suite of developers to work on something. They don't need these super fast systems. Or let's just say I'm using a very simple chatbot. Well, do I actually need something to be as fast as an A100 or an H100 or an H200? So almost typically we're talking about these particular GPUs, and so I grabbed this the other day. I mean, they are fast. They're pretty incredible machines. I'm a hardware person myself, but yeah, I grabbed some of the rough prices that you might expect out there without giving our exact prices that we pay. But yeah, an H100, you're north of 25K a piece. The A180 gig, you're north of about 13K right now. So if people are getting better prices than that, please come talk to me later. I'd like to know about that. But they're super fast, but they're incredibly expensive. And that's just the card, right? Like you got to put it in a box. You got a box around it, and that box is going to be a high-end box because it's got to handle all this power that's actually running through this stuff. So people kind of laugh at me like, you definitely have the 1 kilowatt, 1.5 kilowatt box, and you know, people just start looking at that and going, okay, this is a real challenge to actually handle all this. So again, you want to make sure you understand some of your use cases because it can really have a long effect all the way down the line, you know, into the data center, into the rack, and trying to get the sufficient cooling for it. And sufficient cooling then can dictate, all right, does it have to be liquid cooled? Can it be air cooled? You know, do I even have space in my liquid cooling or in my air cooling space? All right. So this one, yeah, so just really quick, this is what we have run through before. The QR code up there will actually take you to our previous talk. So I wasn't, you know, again, myself not being close enough to it, I can't take you through the demo like they would have. But that's got the, where we actually did the virtualization, and this was a talk at a previous year or two's. So MIG is essentially where you take the card and slice it up into virtual, and you can do it, it's typically right around the 7. So like I've got the example up there. If you're doing a 40 gig, you can slice it up 7 times, and you end up with a GPU that's got 5 gigs of RAM available to it. And then of course you can attach the VM directly to that. These things are all done relatively straightforwardly inside of OpenStack, and again, the other video there covers that. You got to watch out. The MIGs are only available A100, H100, H200. And you have to use time slicing for a lot of the other GPUs that are out there. We're not as familiar. We don't actually do that as much. It's actually more common for us to attach the GPU directly to a VM, or somebody maybe is using it bare metal, or to use MIG. Of note, I think they still require, there's licensing that is associated with that. I've kind of lost track of what, so the licensing has been around for a while, so you have to set up this licensing server, which is a bit of a tricky thing. But I do know that some of the Intel GPUs that are coming out are not licensed that same way. So I think that maybe it's my own wishful thinking, but the community is hopeful that some of this licensing stuff will go away because it's an added layer of cost and complexity. All right. So this one actually, so this is really intended just for, I don't know if you can actually take a picture of that. That's actually what you can do to get MIG running. So I don't know if that's something, of course, you'll be able to look at and see inside of the deck later. But that's essentially, this is our developer, Raphael. They're helping me out with what it would have been like if he actually was able to run that demo. All right. So I'm going to jump then to just the CPU, that pretty much everybody's familiar with the GPUs and being able to run these workloads on GPUs. So I'm going to actually spend a little bit of time on the CPU. And in this case, this is Intel, so I'll just cover that one today. But essentially, in the 4th generation, they added some specific silicon. You can see that up there, TMUL, if you need to look that up. But essentially, it's AMX extensions in the 4th generation and the 5th generation. Now give you specific silicon accessible by each of the cores that can actually run some of these calculations for you. So you may remember like back when Intel added like to do encryption, right? So it's very similar to that. This is a specific silicon to handle this workload. Right now we only run up to the 5th generation. For those of you tracking Intel, with the 6th generation, the P cores will have this, but they're very power hungry. They're really big CPUs, partly because they've been putting all this stuff in it. And so we haven't actually made our shift yet 2 P cores, to the Xeon 6. So I'd love to, if anybody's got their own opinion on that, maybe find me afterwards. I'd love some advice because it looks like they're both going to be tricky to get into boxes and quite expensive. And again, it's just the power envelope. When the power envelope gets too big, it gets pretty hard to get in a chassis. So let's see, hopefully this will play. This is just, so I'm going to switch over now to when you're setting kind of expectations for, or requirements for your, oh boy, I can't see that. Setting requirements for what you might be trying to do with your workloads. All this really is just, you can see, right, labeled up there, 25 tokens per second, 50 tokens per second on the side. The point that we're just trying to make here is that when you're a human and it's a human interaction with an LLM like this, your 25 tokens per second is plenty fast. It's faster than what a human is going to be able to interact with it anyways. So it helps you just give some perspective about like, well, what am I actually going to need to design against? And so I know I'm switching all the way between like data centers, you know, and power issues, and then all the way to like end use cases. But the reason for us that we end up doing this is when we as a company are learning our new technology, and again, I'm 100% Open Metal is very much in that stage, is we like to talk directly to the customer and figure out what you're doing and understand in depth what is the issue that you're facing. So in some cases, we're down at this level going like, well, what are you trying to accomplish out of this? So like recently, we're having somebody come off of AWS using their natural language tool, Transcribe, AWS Transcribe, and it's a huge bill that they have, and we have to figure out, okay, you got to get off of that. Their business model is not going to sustain that. It's now put us into the natural language processing and us understanding how to use Whisper in order to accomplish these similar things for them. But that's why I say, like, so for us, hopefully this is useful that I'm switching, you know, back all the way down to the data center and then back up to use cases. Yeah, but so again, that was trying to show you that when you set your requirements, it can often help you go, okay, is this going to be CPU? It's going to be GPU. Where are we going to be with this? All right, let me see if I can get myself moving again. Yeah, so again, so this is kind of following that same vein. The developer only had an A140 gig available to run these tests on, and then running them against the CPUs. But you can see up there, you'll end up with getting familiar with tokens per second. This is, you know, just what the system can handle, how fast it can actually push these requests through. So in this case, I've got a few tests that I'll flip to, but 30 tokens per second, you know, chat, code assist, document summary, these are often human interaction related things. And then if you're over in like fraud detection is one we were actually working on recently, is you end up actually having to have really high throughput. So in that case, you know, maybe something like a CPU is not going to make sense for you, and you're going to be over on a GPU. It's starting to become a little more common where people are using systems that make multiple calls to the LLM before it comes back and shows the human, you know, what's going on. So you got to account for that. So in that case, you might be processing 2 or 3 times, and then you're going to end up in the higher processing tokens per second requirement. Some of the other things to watch out for, yeah, accuracy level requirements. Actually, one of the engineers that we were just talking. He was trying to use one of the smaller LLMs to produce some JSON, some pedantic JSON data set, and couldn't get the lower accuracy model to actually produce it accurately. And so it would have syntax errors inside of there versus the higher cost one, more accurate one was producing it correctly, reliably. And so there is trade-offs, so certainly you're going to find out as you start to work with these. But I would encourage you guys to have the models available to you to flip back and forth. Then you can make decisions like that to say, like, no, actually it works fine for this business model. Right. Something to always note about the CPUs is, of course, you know, these are general purpose. It's a CPU. And so you may already have lots of unused CPU in your systems out there. So this is not uncommon that people end up with a lot of CPU. Run out of RAM in your OpenStack, but you've got a lot of CPU left over. So it might even be that you've got resources that you can use now. So kind of free in that case. All right. So I don't really know that much about that one right there. So we'll have to move through that one. All right, so here's some other things that we found. So now I'll get to share with you some of the stats that actually came out of the testing. So in this case, why exactly it's doing this, I don't think I can speak exactly to what that is. But as you can see here, that in some cases when you, and again, this is a Llama 3 billion quantized down to 8, is that the tokens per second actually was performing highest at utilizing 64 threads or 32 threads. It's a 128 thread box. And I think we're still trying to puzzle out what those could be. It could be that these are also the governor is set to performance or what the schedule util. Don't use on demand for this. I mean, you probably may know that already for various use cases, but that's going to give you a penalty hit because it's trying to shift itself up and down performance-wise, so don't use on demand. But yeah, as you can see here, you may end up figuring out like where your sweet spot is inside it. It's going to be CPU specific, and then we've got 3 CPUs that we tried it against just to be able to show people what they might expect. Just for fun, he was kind of switching the AMX on and off on there. Yeah, and you can see we tested the 4510, the 6526Y, and the 6530. And again, we ran it with half the threads only whenever we were doing this test. And then you can see the top number there, for example, on the 6530, it was running 53 tokens a second. 46 with the gold. It's considerably less threads, but actually that one actually has a higher clock speed than the 6530. So those are 3 pretty common CPUs that you see out there. You guys probably might have them in your clusters already. Yeah, he ran this again, so you can see something similar. This is for one of the distilled DeepSeek models. Yeah, and also you could just see the difference there. It is kind of interesting, you know, again, that particular CPU, the 6526Y, that's turned out to be like a workhorse for us, very popular with our customers for a whole bunch of different purposes. All right. I'm gonna read you just a little bit of this because this was some good findings, but again, I'm not as familiar with this stuff. So, Llama CPP, yeah, lightweight this was definitely one that this is Raphael, sorry about that, that's his favorite now. There was some tweaks that had to be due to it to get it to really efficiently run on top of CPUs, but that actually turned out to be something that he is now turning to regularly. And Intel, PyTorch, of course up there, OpenVINO. If you're not familiar with OpenVINO, that is Intel has put that out to be able to access, these are the libraries, to be able to access the stuff that you need on the CPUs. But that's Intel's toolkit. All right. This is just kind of helping you understand where these fall in comparison. That is the A100 and what it can process, 171 in this case. But again, this is a purpose that particular one with the 40 gig, I would guess, was probably like it's probably $9,000 or $8,000 or $9,000 if you're buying it now. And again, that is just the GPU itself. And so whenever you're looking at this stuff, you're going to be balancing the cost versus what the thing can actually handle. All right. Yeah, this one is just, again, reminding us that this is in flux. This is changing. So the skill sets of these open source, this is off a Hugging Face, so it probably should be quoted there. But this is just essentially how the accuracy of these models are increasing, but they're also becoming lighter and lighter weight. And as that happens, that frees you up to be able to run these in a lot of different places. It could be CPUs, it could be multiple instances running on a single GPU. So something of importance, when you've got a small model, you can of course run multiple at the same time on GPUs. All right, This one, so if you guys don't mind, I'm gonna turn a little philosophical here. But actually, we have one of our customers, and it's a company actually that I work with as well. It's called OpenMaya, and it's also the application's published under CircleBot.ai. And just open metals always have this philosophy of simplifying open source, large-scale open source. And when I look at the ecosystem that's around AI, it's a pretty complicated ecosystem. And so I was excited that where we may be able to sit as a open source community is both in the OpenStack world and just leveraging the philosophies that we all have in the OpenStack world. How do we apply these to the AI world? And one of the things, and we were just having this discussion at lunch, is that a lot of this is currently dominated by very, very large organizations, very large, and only getting larger, if it keeps going this direction. And for me, when I think of OpenStack and where we can fit in the AI world, partly it has to do with the community. The community is one of these rare communities that has the ability to have a scale that fits and can fight against some of these larger organizations that to me feels like they're gonna really try to dominate and drive forward the utilization of this stuff. And sometimes you even hear this whatever Altman there's got to say about it's time to replace your developers with this AI kit that they're putting out. These kinds of things. This doesn't seem like a great thing in the world. And so for me, when I think about OpenStack, open infrastructure, and this community around there, is there some of the things that we can do as a group to help bring AI to a democratized, for lack of a better term, to help people be closer to it, to learn it themselves, understand the business models, and to be able to change directions of the larger group, to support, hopefully, what I would call the non-big AI business models, and let people be closer and more fundamental with AI. So, yeah, that's what I had to say today. So, yeah, just one last thing. If you guys want to get in touch with any of us or just kind of keep up with what's going on over at OpenMetal as we're starting to roll out our AI products. Hopefully this stuff was useful. Everything, again, I touched from a data center, all the way up to, tokens per second. So, all right, this is, again, this is the crew over there that you could get a hold of that's kind of front facing. Raphael and I. And Raphael, sorry he couldn't make it, but I know it's recorded so he can watch me talk about him later. Cool. All right. Yeah, that's what I've got for today. Is there questions, or I think we can wrap it up? No questions? All right. Who wants to tell me what they looked up and how to take the best way to take the temperature of your child? We'll circle back to that. Cool. Okay. No, thank you very much. And again, please come and chat with us.